right, time for another draft. Physics.com, debatephysics.com also. But again, debating imbeciles, it's just no point. The arguments are so bad, so empty. So, conventional physics implies things, and the physicists sort of run away from what it implies. Now, somebody did write a book, and telling bowlers that they should be using a lighter bowling ball because it's, twice the energy. You can manifest twice the energy hitting the pins by using a lighter bowling ball. And obviously, none of the professional bowlers said this is possible. They couldn't find it in reality. So that theory didn't seem very strong as a theory because in practice they can't make it work. And again, it goes even worse. So if I take a 5-pound ball versus a 16-pound ball and I throw the 5-pound ball 3 times faster, the prediction is I can knock down 9 times the number of pins. Either 9 times the energy I can deliver to the pins. And again, the quarter-size ball thrown, what would that be? 4-pound ball thrown 4 times as fast, 16 times, right? So again, the simple argument is that their physics claims, it implies, it states that somehow this happens. To spin a motor 5 times as fast, you have to apply 25 times the fuel, the electricity, or the gasoline. That a thing spinning 5 times as fast somehow will produce 25 times the energy of it spinning, 1 rotation a second. So 5 rotations a second is 25 times the energy of 1 rotation a second. Now, everybody's common experience says bullshit. Experience over a lifetime says bullshit. Okay, driving a car, all the experiences we have, this doesn't happen. Okay, you don't pay a huge fuel increase price for going faster. It's just not true. You go twice as fast, use twice the fuel. You go 3 times as fast, use 3 times the fuel, not 9 times the fuel. So this argument shouldn't even be taking place because first they have no evidence demonstrating this miraculous claim. So they just claim it. They don't produce any physical evidence. And now and then they'll imply something about braking distance, right? which is about how you take the energy away. And clearly you're not taking it away in some manner where you're measuring it. Okay, you're just measuring it by distance, which doesn't tell you anything about the actual amount of friction and the heat that you've transferred. So again, it's just completely ridiculous. In the 1700s, they had little clay experiments where they dented clay with round objects. Clearly, a round object isn't a linear flat surface. And depending on how deeply you go into the clay, you will have an advantage, okay, if the deeper you go, because the deeper you go into the clay, the more you're pushing clay sideways than you are pushing clay down. Simple logical arguments, they can't refute any of them. They can't counter any of them with evidence, and yet they just keep arrogantly pontificating that this Messiah exists, this MV squared crap. And I can keep telling them, okay, I can keep saying to them, I know that when I lift 5 pounds, it doesn't feel like 25 pounds. That is, I don't have to put 25 times the energy in to lift 5 pounds versus 1 pound. It's just 5 times the energy. And I can feel it by just having a 1 pound next to a 2 pound next to a 3 pound, and I can lift them, and I can feel that, it's only 1 extra pound. And the same thing with pulling a spring. I can feel that, yes, it's only 1 pound of difference, and then 1 pound of difference, and then 1 pound of difference. It's not exponentially or quadratically harder to compress the spring. So we just add the same energy. So in spite of the fact that this Ryan Gosling guy actually did an experiment, proved Lenz's law, proved that to compress a spring twice as much only requires the addition of 1 unit of energy, not 4 units of energy. They just keep babbling, and I don't know if there's anything that can be done about it. I mean, there's just no point in responding at this point, right? Because I've made all these arguments. They've ignored all of them. Again, they claim you can't change how much pressure you put on ice by traveling quicker over the ice. That somehow you will, change what your gravitational impact is on the ice by moving quickly across the ice. Things that work, they're telling you don't happen. It's just ridiculous, the argument, and I shouldn't have to keep going over it. So I'll go over what I'm going to claim is, frankly, the truth. Gravity is a stream of energy. Okay, the fact is it's not just some sort of bent geodesic. I guess I'll make another video about this also, just because their obnoxious resistance to the simple explanation is just amazing. Okay, it does everything exactly. It has so many correlations and connections to other mechanisms. So apparently when you have a convergence, that is, energy is converging into a center point, we call that a geodesic, a bent geodesic. But when the sun produces energy exactly in the same proportions, that is, it's just the opposite direction, so it's a divergence from a center out, we don't call it a bent geodesic. We don't draw it as some silly mountain, instead of a well. We don't do any of that nonsense. It's doing exactly the same thing, okay? I mean, gravity is a convergence, and light from the sun is a divergence. And it's exactly the inverse square law, exactly the same mechanism. It follows exactly the same rules in terms of your acquisition of photons will be exactly the same, except opposite in terms of volume. As gravity. It's what gravity is going to do. It's a stream of energy, one going in and the other one's going out, but it's exactly the same. So these are perfectly reasonable correlations to draw. So I noticed that in Gosling's silly videos, he's using a thing that says PE equals 1/2 KE squared. And again, I've pointed out, there's potential energy has nothing to do with any of this, okay? It's just almost a silly word, all right? Because I could have a stream, okay? So it's just a river, all right? And it's flowing at a certain rate, okay? It has a certain amount of energy per unit of time passing a certain point. So just like sunlight coming through the atmosphere, there's a certain volume of photons per second that travel through a certain volume of the atmosphere. And the same thing's happening for the stream, so you can just understand it that way. And I could have a boat, okay, just sitting here on the shore. And the argument is, does the boat have any potential energy? And what would the potential energy be? I mean, the fact is the boat, I put it in a stream. Let's say the stream's flow is 25 miles per hour, the peak speed of the bits of water. You kind of know, well, the peak speed I can get is 25 miles an hour. All right, so if I throw the boat in the water, but we know that it's completely dependent on when I pull the boat out of the water. So there'll be a time when the boat's accelerating, and then at a certain distance, it's going to go 25 miles an hour, and that's it. It's not going to go any faster. 25 will be its peak speed, because that's how fast the water's going. Can't go any faster than the water's going, so it's stuck with just going 25 miles an hour. But all through this period, it's going to be going different amounts, 1, 2, 3, 4, 5, 6. So it just depends on how long I allow it to go in the stream will decide how much potential energy it has, right? So the potential energy, they should just say straight up, it's about how much time you're going to let the thing be in the stream of water. You wouldn't say it's about the distance, it's about the time. Because the distance is sort of going to be corrupted by the fact that it's this 25 mile an hour maximum. Now in gravity, okay, the simple difference between gravity is this speed is 3 million meters per second, okay. All right, so the speed of the stream is really high. So obviously it'll take a very long, a lot of exposure to the stream before you're going to be going 3 million miles an hour. Okay, it's a piece of matter. So you will be constantly accelerated through a very long amount of distance because of the huge differential between 0 meters per second and 3 million meters per second. All right. And so that's substantially the only difference. So we're just talking about, we could do exactly the same kind of experiments. We could put a cement block in the stream and put a spring on it, and we could hold the boat in the stream. And the fact is, the boat, okay, will collect the pressure, and it doesn't matter where in the stream I do this. It doesn't matter where I put the cement block. It doesn't matter where. The spring will collect the pressure that the stream is able. The spring will show you how much pressure the boat is collecting. Okay, and that's it per unit of time. And that's all it can be, as a per unit of time. It's not traveling any distance. It's just stationary. And it's going to expand this spring. It's going to remain stationary. And the fact is, the constant force is what it's going to be measuring. The constant pressure created by the 25 mile an hour stream. And so this will be a certain expansion. And all that expansion can do, okay, the only energy that has, frankly, okay, is the energy you put in. So any spring, like any elastic surface, I can hit it with energy, and I can only get back what I put in. I'm only going to get something shoot back up in gravity, for example, a bouncing ball or something at best. Now, the ideal isn't what we ever have, so we only get 80% if we're lucky of the energy back, or 90. You know, you can use ball bearings, hard steel, different things to get back more and more of that energy. But in most circumstances, you're going to lose, 10 to 20% because of the poor efficiency of the springs. And the fact is you can understand some of it, because the spring, as the spring accelerates, as you allow the pressure this way, okay, the pressure, let me see, I guess I should do it with the example of you take away the force pushing it, and you allow the spring to be free to move. The spring can only move at a maximum speed, and the fact is that it's going to get the object up to some speed, and the spring's still going to have energy left over. It's going to be moving fast in the beginning and then get slower, and the thing you're pushing is going to be slower and then faster. And there's going to be a point where the spring speed is going to be below the speed of the object. So the spring cannot deliver this portion of the energy to the object because it's just not moving fast enough. So that's one reason why you have built-in structural losses when you use a spring, is because the expansion speed will not be sufficient to assure that you get all of the spring's energy into the object. All right, so you can understand these simple things. All right, and the simple point is, if I put two boats in here, right, there's now only 2 units of force. The force of this is the stream's applying is now doubled, because there's 2 things to collect the force, and that's it. So whether they're 2 independent objects or just one object of the same size, the same capacity to absorb. So obviously with the stream, it's surface area, and in gravity, it's mass. But you can understand that the correlation isn't destroyed because there's the specific cause of how the collecting is done is a little bit different. A sail is different, but the idea is the same. You're just collecting the wind. All right. And yeah, so that's it. There's just 2 units of pressure. You can only get 2 units of pressure back. If I was to take this twice the compression and I took one of the boats off, the other boat will spring back, because now the spring's compression is twice, so it's going to spring back, but it's only going to spring back 1 unit of distance. It's still going to be, collecting 1 unit of force, okay, and it can't get that back. So the simple experiment I've pointed out, that physics should have done decades ago, or if not centuries ago, and they haven't done it. They've avoided the simplest experiment. So they claim that if you drop 4 pounds, 1 foot, it's the same energy as 1 pound dropped 4 feet. All right, and it's not the same momentum is the obvious point. We already know what the velocity is going to be. So 4 times the height only gets you twice the velocity. So it's 1 pound with twice the velocity. This is 4 pounds with 1 velocity. Obviously, this has to, because it has more momentum, have more energy. This has to compress the spring more. It has more capacity to do work because it has more momentum. So they don't believe in conservation of momentum is the bottom line. To claim that these are equal energies is to deny what we know about momentum. So yes, the 4 times the distance doesn't mean anything. It's not 4 times the energy because it's 4 times the distance. And you can understand that because it's only twice the time in the gravity. So again, they just keep ignoring the fact that it's twice the time in the force. So like the stream example, it's just about how long I put the boat in the stream will decide how much energy the boat can collect, how much velocity it can collect, not the distance it travels. It's about the time. The time having the force push on it. It's just obvious that's the truth. So this simple experiment, they haven't done it. And then I'd almost argue, even almost simpler experiment, that I've pointed out this is what's going to happen. I put a mouse, on the scale, and it's going to weigh something. Who cares? Let's just say it weighs 1 pound for this hell of a big heavy mouse, ratty mouse maybe. Anyway, and then I turn the scale sideways, so I lock the position of the spring. So now I've stored the energy, and all I've stored is its gravitational energy. How much energy gravity is constantly pushing on the mouse with that the scale can register, the difference, the gravitational difference. And the fact is the mouse will leave at 1 mile an hour, which is, I said it wrong the other day, it's 0.44 meters per second. That's what the mouse will leave at. And because it conserves momentum. That's the velocity that's relevant to this mouse to get this register on the spring. And if I did the same experiment with an elephant, yeah, elephant, a little chunky thing. All right, and I get a compression, and I do the same thing. I turn the scale sideways. Release the energy. The elephant will go 0.44 meters per second. It's exactly the same velocity. Because the constant force was the same that created the weight pressure. And you're just going to say, that's all the force I have. It's the force that I put into the spring. So yes, this registered 2,000 pounds versus this registering 1 pound. So obviously, all I want to get, though, is the same velocity. We know if we drop those things in gravity, they're going to fall at the same speed. And if I push them with the same spring compression they create, they're going to move with the same speed, and the momentum is going to be perfectly conserved. And there's not going to be any capacity to do any 4 times the work. So again, they're claiming that if I have a scale, and I compress the spring 1 unit, that I have 1 unit of energy. So let's say that when I tip the scale sideways, that shoots a 1 pound object at 0.5 meters per second. Just doesn't matter what we use. So it's 1 pound at a half a meter per second velocity. That's all it can do. That's 1 unit of spring compression. They're saying that if I compress the spring twice as much and then shoot this same 1 pound, that I'll get 2 velocity. That I'll get 4 times the velocity out. I can't change the mass, so the only way I can make this more energy crap happen is I have to change the velocity. So they're basically saying that I could put 4 1-pound objects in front of that 2-pound spring, and I'll get the same velocity for all 4 of them. Okay, I'll get the same 0.5 miles per hour. Okay, let's just say, or meters per second. I'll get exactly the same velocity. Even though I only compress the spring twice as much, I'll get 4 times the amount of energy. So again, it's like them saying, you know, you can lift 2 pounds and put on a spring, and now you have 4 pounds of energy. No, you don't. You only have 2 pounds of energy. You only have the capacity to move 2 mass at that 0.5 speed. That's all you have. So this is a simple experiment, right? I mean, this is really simple. So he sits there and makes these arguments. He does all these other wacky, silly experiments. I mean, this one doesn't seem that challenging. So you're just saying, I'm going to compress a spring 1 distance, okay, and then I'll launch something with it. And then I'll compress it 2 distances, and I'll take 4 of the same thing and launch them and see if they go the same speed. Because he's claiming they'll go the same speed. And obviously I'm claiming no, they'll go 1/4 the speed. There's 4 of them. Well, you've compressed the spring twice as much, so they'll go half the speed. You can, there's no other way around. You can't come up with some other. You have to conserve the momentum. Again, Professor Lewin, do I have to play the clip again? They just keep ignoring what the real physics says, and they're claiming they're defending some sort of real physics. They're claiming as if this has been established as a proof somewhere, that somebody proved any of this, and it's all just a lie that they have done any of that. A pathetic, crazy, silly lie. And the fact that none of these experiments exist proves it's all a lie. Because if they did the experiments, the results aren't going to come out their way. Brozo did the lever experiment, okay, launching uses the same spring energy, okay, and then launches a half mass object and a full mass object, and the half mass basically goes twice as fast. It doesn't go 4 times as fast, and it doesn't go 1.4 as fast. So that's the irony of this whole conversation, is Brozo basically proved that springs compressed twice as much only produce 1.4 the extra velocity. That they're pretty lame in terms of what they do to momentum. They completely wipe momentum out. And these assholes are almost complaining, arguing the opposite, that twice the compression of the spring is somehow 4 times the energy, and Brozo was only getting 1.4 the momentum back. But anyway, his claim anyway. Obviously the experiment didn't come out his way. It didn't prove that. So again, this is the context. Again, we have Dispar's lab, the pathetic liar, did the experiment with the hammer. And he put the 3 mass, the extra mass, he's doing the 4 mass compared to 1 mass, and he puts the 3 mass in the wrong location and gets an equality, almost an equality. He actually didn't even achieve the equality. And clearly, if we put the 3 mass in the right location, it's going to dramatically increase the amount of energy the 4 mass has. So clearly, it's an experiment basically providing a proof that it's not the same amount of energy. Because obviously, if you did the experiment correctly, the answer is not going to be that they have the same energy. Obviously, if he changes the experiment, he's not going to get the same results. So obviously, he basically inadvertently proved exactly the opposite of his claim by doing the experiment badly. So that's the context, and these assholes are just talking babble. So I'll read a Piro comment. I'll play the end of a Gosling video, but it was just a waste of time. He didn't say anything, didn't prove anything, didn't demonstrate anything, nothing, just nonsense. Just absolute nonsense about what springs collect. They're collecting a constant force, and they're going to give back an impulse. They can't give back a constant force. They can only give back the impulse energy. That's it. They only have a constant force when you're applying a constant pressure against the spring. So if you put a constant pressure in, then the spring will have a constant pressure resistance. But that's it. If you release the force, the constancy of it, then it's just all impulse energy. So all you can do is measure the velocity, but you can't measure the constant force. But anyway. Alright, so I'll find the Piro comment, which shouldn't be too difficult. Alright, so he just says, okay, again, not capitalizing his first sentence, which just seems so lazy. The forces during the second half of the spring stretch are greater. So again, he keeps just saying this silly word, are greater. Greater than what? Yeah. I mean, obviously, compressing the spring twice as much is twice the force. Your argument is it's 4 times the force. So show me a piece of evidence somewhere on Earth demonstrating that it's 4 times the force to push the spring twice as far. Show that somewhere, because it's not true. Okay. Stretch are greater than the forces of the first half. Yeah, the point is that it's greater by the increments, 1 pound, 2 pounds, 3 pounds, 4 pounds, 5 pounds. 4 pounds, 5 pounds is only 1 more pound than 4 pounds. That's it, just 1 more. 1 more unit of energy. That's it. Thus, more force will be collected. Yes, that's all the spring can do is collect a certain amount of pressure, but it can't release a constant force. It can only release an instantaneous bit of energy. In the second half, since the forces are greater. So again, it's just absolute mush. That's not the argument. The argument is about whether it's more energy to push the spring twice as far. Of course it takes more energy to push the spring twice as far. Nobody's arguing it doesn't take more energy. What we're arguing is the difference between twice as much and 4 times as much. So you have nothing indicating it's 4 times as much. Greater force collected means more energy. So again, I'm going to delete this one just because it's so fucking stupid and useless and pointless as a comment. More? This subject isn't about more. The subject is the difference between 1 plus 1 equaling 2 and 1 plus 1 equaling 4. You have to prove the 4 part, moron. God damn it. I should just delete all of his mushy comments. I guess I should put my reply links to these videos. Just disgusting people. All right, so let me go find the Gosling video. All right, so just a complete nonsense video. He says, look, you put the weight on, then you release the spring. He doesn't even account for the fact that the spring can only give you back what you put in. It's just silly. He doesn't say anything, doesn't demonstrate anything, doesn't say anything rational, and then ends with this nonsense.
To there, take the weight to there, down to there, take the weights off, release the spring, done its work.
So, done its work. The whole argument is about how much energy is in that spring. You're claiming there's 4 times as much energy when you compress the spring twice as much. And Hooke's law basically obviously shows that no, it's 1 unit of energy to do this, and it's a second unit of energy does that. And it's no more than that. 2 mass is just 2 mass. It doesn't do the work of a 4 mass. It can only do the work of a 2 mass. All right.
Here, ground level, 2 units of distance for the one way.
So again, the amount of distance is irrelevant. It just doesn't make any difference. You're never going to get back more from the spring than you put in. So it's irrelevant. You'll never be able to change how much distance you raise a mass to create a displacement in the spring. You can't make free energy. So all the spring can do is restore itself back to where it was. If I incrementally reduce gravity, so you put a 1 mass on the spring is compressed. Now I incrementally get rid of gravity, the weight just rises back to 0.
I mean, honestly, it's incredible. Despite your accusations of people.
So yeah, the accusation is that you have to be the biggest pile of lying suck to sit there and say you have any evidence, that you've proven anything, that science ever proved this existence exists, that they ever did this experiment where they dropped 4 pounds and they dropped 1 pound from 4 times the height and proved that there's inequality. This never happened. All right, you're just a lying piece of shit to imply anyone has any good reason to believe in 1/2 KE. Nobody has a good reason to believe that. It doesn't happen anywhere in reality. It doesn't happen on bowling alleys. It doesn't happen with wrecking balls. It doesn't happen on levers. It doesn't happen anywhere on this planet. It certainly doesn't happen with ballistic pendulums where you lose 99.94% of the kinetic energy just disappears from the universe. You can't account for where it is at all. You have zero explanation. More of the momentum, you conserve 99% of the momentum. You only have 1% of lost energy. You don't have 99% of lost energy anywhere. So again, prove it somewhere that, that somehow without losing any momentum, I add a 5 mass to a 5 mass. So I have a 5 mass moving a velocity. I add another 5 mass to it in a passive way. The object is now going half the velocity. All the momentum is perfectly conserved, and yet you claim there's a bunch of energy somewhere, that a bunch of energy was lost. Half the energy disappeared, yet you show no heat, you show no evidence whatsoever at all of where that energy is. You just claim it was lost somewhere, it magically seeped somewhere. You have no experimental evidence demonstrating a single piece of this rubbish theory. And yet you talk this arrogance. You fucking Muslim. You disgusting, jihading retard.
I've never seen anybody that's so stupid.
Yes, well, you're so stupid. He has a video up. He left the video up, okay, 4 or 5 videos ago, where he claims something completely imbecilic, knows it's wrong now, and he left the video up. Completely deceptive, complete statement in the video that's completely wrong, and he's done nothing to correct that. And he's calling somebody else stupid?
We can't accept these basic things.
So where's the basic? Again, it's the basic nowhere. It doesn't happen anywhere in reality. Nobody's using 25 times the fuel by going 50 miles an hour than versus 10 miles an hour. Nobody. Nobody on this planet right now is losing, is having to use 25 times the fuel. They're using less even. 3 times the fuel to go 5 times as fast. That's the reality.
A great definition of an internet crank, you really are.
Yeah, and you're a perfect definition of scum. Fucking lying, dishonest sack of shit. Fucking scum, okay? You know you don't have any evidence. You know the theory hasn't been proven. You know the science absolutely sucks. You know it's just a goddamn fucking story, a fucking fable. You know all of those facts, okay, that this was never established as a truth, okay? It was never established that 4 pounds dropped 1 foot equals 1 pound dropped 4 feet. Then it was never proven that denting clay is a great idea, a great way to measure energy. So at no fucking point in the history of this nonsense theory has it ever been proven with anything called a credible piece of fucking goddamn evidence, and yet you arrogantly talk like, oh, you'd have to be an imbecile not to know that it feels like 25 times the work to lift 5 pounds. 5 pounds feels 25 times heavier than 1 pound. Everybody knows it. Oh, fuck you, liar. Oh, disgusting. Okay. Amazing pieces of shit on this planet. What a dishonest, lying sack of shit.